Hello everyone, you're welcome to solve this nice exponential equation, which is 4 to the power of a times 4 to the power of a. This is equal to 400. What is the value of a given that a is not equal to 0? So let's provide a solution from here. This exponential equation is in the form of a to the power of n multiplied by a to the power of m, which we can express as a to the power of n plus m. Applying this exponent property, then here we have, applying this exponent property, here we have 4 to the power of a plus a. This is equal to 400. So this means we have 4 to the power of a plus a, which is 2a. This is equal to 400. To solve for a, we introduce logarithm on both sides such that we have log 4 to the power of 2a. This is equal to log 400. Now, log 4 to the power of 2a, this is in the form of log a to the power of n, which we can express as n log a. Applying this power rule property, then log 4 to the power of 2a becomes 2a log 4. This is equal to log 400. So let's divide both sides by log 4. Also here we have log 4. So let's simplify log 4 and log 4 here so that we have 2a. This is equal to log 400 divided by log 4. The next step is that we can express 400. This is the same thing as 4 multiplied by 100. And this implies we have 2a. This is equal to log 4 multiplied by 100 divided by log 4. So this means that we have log 4 times 100, and this is in the form of log a times b, which we can express as log a plus log b. Applying this logarithm property, then we have that 2a is equal to log 4 divided by log 4, then plus log 100 divided by log 4. Now the next step is to simplify log 4 and log 4 here. So we have 1. So 2a, this is equal to 1 plus log 100 divided by log 4. We can express 100. This is the same thing as 25 multiplied by 4. Let's substitute this so that we have 2a. This is equal to 1 plus, this is log 25 multiplied by 4. Everything here divided by log 4. So now log 25 times 4. This is in the form of log a times b, which you can express as log a plus log b. So this means that we have 2a. This is equal to 1 plus, this is log 25 divided by log 4. Then plus log 4 divided by log 4. So let's simplify log 4 and log 4 here. So this is 1. So that now we have 2a. This is equal to 1 plus 1. This is 2. Then plus log 25 divided by log 4. So now we have 2a. This is equal to 2 plus, we can express log 25 as log 5 to the power of 2 divided by log 4, which is log 2 to the power of 2. Now applying the power rule property here, we have that 2a, this is equal to 2 plus log 5 to the power of 2 becomes 2 log 5 divided by log 2 to the power of 2, which is 2 log 2. So let's simplify 2 and 2 here so that now we have 2a, this is equal to 2 plus, this is log 5 divided by log 2. Now we have that log 5 over log 2, this is in the form of log a divided by log b, which we can express as log a to base b. So let's apply this property. So you're saying that log 5 over log 2, this is in the form of log a over log b, which you can express as log a to base b. So we have here 2a, this is equal to 2, plus this is log 5 to base 2. So let's divide both sides by 2. Let's simplify here, so that now we have a is equal to 2 divided by 2, this is 1, then plus a half, this is log 5 to base 2. So this is the value of a, this is the value of a. The next step from here is to verify that this value of a satisfies the equation. So let's verify from here. Now, if you recall, we entered 4 to the power of a multiplying by 4 to the power of a. This should give us a value of 400. Now we see that 4 to the power of a times 4 to the power of a, this is in the form of a to the power of n times a to the power of m, which we can express as a to the power of n plus m. Applying this exponent property, this means we have 4 to the power of a plus a. This should give us a value of 400. So this means we have 4 to the power of a plus a, this is 2a. This should give us a value of 400. So let's substitute the value of a here. So we have 4 to the power of 2 multiplying by a, which is 1 plus a half. This is log 5 to base 2. Cross the parentheses. This should give us a value of 400. So let's open the parentheses here so that we have 4 to the power of 2 times 1. This is 2. Then plus 2 times a half log 5 to base 2. 2 and 2 here simplifies. So we have log 5 to base 2. This is supposed to give us a value of 400. The next step from here, we can express 4 as 2 to the power of 2. So that now we have here 2 to the power of 2. Into the parentheses, we have 2 plus log 5 to base 2. Cross the parentheses, this should give us a value of 400. So let's open the parentheses here. Then we have 2 to the power of 2 times 2. This is 4 plus 2 times log 5 to base 2. So this is 2 log 5 to base 2. This is supposed to give us a value of 400. So 2 is a power here. So we can express this as 2 to the power of 4. Then plus log 5 to the power of 2. Then to base 2. This should give us a value of 400. So 2 to the power of 4 plus log 5 squared to base 2. This is in the form of a to the power of n plus m, which we can express as a to the power of n multiplied by a to the power of m. So we have 2 to the power of 4 multiplied by 2 to the power of log 5 squared to base 2. This is supposed to give us a value of 400. Now, 2 to the power of 4, this is the same thing as 16. So we have 16 multiplied by 2 to the power of log 5 squared to base 2. This is supposed to give us a value of 400. The next step is that 2 to the power of log 5 squared to base 2. This is in the form of a to the power of log b to base a, which essentially is equal to b. Applying this logarithm property, then 2 to the power of log 5 squared to base 2. This is the same thing as 5 squared, which is 25. Let's substitute 25 back to the equation here. So we have 16 multiplied by 25. This is supposed to give us a value of 400. Now, 16 times 25, this is 400, which is equal to 400. So the left hand side is equal to the right hand side. And this proves that the value of A, which is equal to 1 plus a half log 5 to base 2, satisfies the equation. So kindly follow the steps, like this video, and kindly